How did humans survive the Ice Age without fireproof shelters? A fire crackles inside a shelter constructed entirely from flammable materials. Animal hides stretched over wooden frames. Dried grass insulation. Bone structures wrapped in fabric. Everything surrounding the flames is combustible. Outside, temperatures hover at -40 degrees Fahrenheit. Without fire, the occupants would freeze to death within hours. But with fire burning inside a shelter made of kindling, the risk of catastrophic burning is constant. One spark, one moment of inattention, one gust of wind directing flames toward walls. The entire structure could ignite in seconds, trapping families inside burning shelters during conditions where escape meant instant death by freezing. Yet for 300,000 years, humans survived Ice Age winters by burning fires inside shelters constructed from the most flammable materials available. Archaeological evidence shows no fire-related shelter destruction, no mass casualties from burning, no evidence of the catastrophic fire deaths that should have been inevitable. How did Ice Age humans manage continuous fire use inside flammable shelters without burning themselves alive? The answer reveals engineering sophistication that modern fire safety experts are only now beginning to appreciate. Part 1. The Impossible Fire Paradox. Fundamental problem facing Ice Age humans was brutally simple. They needed fire to survive, but fire could kill them just as easily as cold. Modern fire safety engineering recognizes several universal truths about enclosed fire use. Fires require oxygen. Combustion produces smoke and toxic gases. Heat radiates in all directions. Sparks and embers travel unpredictably. Any of these factors can cause catastrophic failure in enclosed spaces. Contemporary building codes require extensive fire safety systems, fire-resistant materials, ventilation systems, smoke detectors, fire suppression equipment, multiple escape routes. These systems exist because fire in enclosed spaces is inherently dangerous. Ice Age humans had none of these protections. Their shelters were constructed from materials that would be classified today as extreme fire hazards: dried animal hides, wooden frameworks, grass and moss insulation, plant fiber textiles. Everything was combustible, yet archaeological evidence from sites across Europe, Asia, and Africa shows continuous habitation of these flammable shelters throughout Ice Age periods spanning hundreds of thousands of years. The evidence shows fire use, but remarkably little evidence of fire-related destruction. Excavations at sites like Terra Amata in France, dating to 380,000 years ago, show preserved hearth structures inside shelters. The hearths show evidence of repeated sustained use over extended periods. The surrounding shelter materials show fire exposure, but not catastrophic burning. This pattern repeats across dozens of excavation sites, evidence of controlled fire use without evidence of uncontrolled fire destruction. The question becomes unavoidable. How did they prevent the fires that should have been inevitable? The first crucial innovation comes from analyzing hearth construction itself. Ice Age humans didn't simply start fires on shelter floors and hope for the best. They engineered sophisticated hearth systems designed to contain and control fire behavior. Excavations at Qasim Cave in Israel, dating to 300,000 years ago, reveal remarkably advanced hearth construction. Rather than surface fires, the hearths were deliberately excavated depressions lined with specific materials. The hearths were dug approximately 8 to 12 inches deep and 24 to 36 inches in diameter. The exact dimensions varied, but the proportions remained consistent across multiple sites and time periods. This suggests standardized engineering, rather than random construction. But the revolutionary discovery comes from analyzing the hearth lining materials. Chemical analysis of preserved hearth structures shows they weren't simply holes in the ground. They were lined with carefully selected materials. The bottom layer consisted of sand or fine gravel, materials that don't burn and have high thermal mass. They absorb heat without combusting and prevent direct contact between flames and underlying earth, which could contain flammable organic materials. Above the sand layer, many hearths show evidence of flat stones arranged in specific patterns. Petrographic analysis shows these stones were deliberately selected for thermal properties. They were stones that could withstand repeated heating and cooling without cracking stones. with high silica content that distribute heat evenly. Research conducted by archaeologists at the Hebrew University of Jerusalem analyzing preserved hearthstones shows evidence of sophisticated stone selection. 93% of stones used in hearth construction at Ice Age sites came from geological formations at least 5 kilometers from habitation sites. This means Ice Age humans were deliberately traveling significant distances to collect specific stones with appropriate thermal properties. They weren't using whatever stones were convenient. They were selecting engineered materials. The hearth design served multiple critical functions. The depression contained fuel and prevented rolling embers from escaping. The sand and stone lining prevented ground combustion. The thermal mass absorbed excess heat and radiated it gradually, reducing temperature spikes that could ignite surrounding materials. But hearth engineering alone wasn't sufficient. Ice Age humans needed to position fires at precisely calculated distances from flammable shelter walls. Analysis of preserved floor plans from Ice Age shelters reveals something extraordinary. Remarkably, consistent spacing between hearths and shelter walls. Excavations at Dolní Věstonice in the Czech Republic, dating to 26,000 years ago, show preserved shelter foundations with clearly defined hearth positions. Modern spatial analysis reveals hearths positioned at distances of 6 to 8 feet from shelter walls, with remarkable consistency. This distance isn't random. Modern fire science recognizes it as the optimal spacing for radiant heat management. At distances less than 6 feet, radiant heat from fires can ignite combustible materials through thermal radiation alone, without direct flame contact. At distances greater than 8 feet, insufficient heat reaches occupants to maintain survivable temperatures. The 6 to 8 foot spacing represents a precisely calculated balance, close enough for heating effectiveness, far enough to prevent ignition. Ice Age humans discovered this optimal distance through empirical testing and maintained it with remarkable consistency. But they went further. Analysis of shelter floor plans shows that hearths weren't positioned randomly within the optimal distance range. They were deliberately offset from center positions and positioned to account for prevailing wind patterns. Preserved hearth arrangements show consistent positioning that would direct smoke toward designated ventilation points, while directing radiant heat toward sleeping and working areas. This indicates sophisticated understanding of airflow patterns and thermal distribution. Perhaps the most sophisticated fire safety innovation developed by Ice Age humans was ventilation engineering systems that allowed smoke and toxic gases to escape while retaining heat. Preserved shelter structures from sites across Europe and Asia show consistent evidence of deliberately engineered ventilation openings. These weren't accidental gaps or damage. They were intentionally constructed openings positioned at specific locations within shelter designs. Archaeological evidence from the Kostenki site in Russia, dating to 22,000 years ago, reveals sophisticated ventilation systems. The shelters show evidence of smoke-darkened openings positioned near the highest points of dome-shaped structures. Modern computational fluid dynamics modeling of these ventilation systems, conducted by researchers at the Technical University of Denmark, reveals extraordinary thermal efficiency. The positioning creates natural convection currents that pull smoke upward and outward, while allowing fresh air to enter near ground level. The system works through basic physics. Hot air rises. By positioning exhaust openings at the highest structural points, Ice Age engineers ensured that smoke and heated air would naturally flow outward. The rising hot air creates negative pressure that pulls fresh air in through lower openings. But the genius extends beyond basic ventilation. Analysis shows that many shelters incorporated adjustable ventilation systems. Evidence suggests that ventilation openings could be partially covered or opened based on weather, conditions, and heating requirements. Preserved hide fragments from shelter sites show evidence of deliberate modification, reinforced edges, attachment points for securing materials, and wear patterns consistent with repeated opening and closing. These were functional components of engineered systems, not decorative elements. During extreme cold, ventilation openings could be partially restricted to retain maximum heat. During milder conditions or when fires burned intensely, openings could be enlarged to increase airflow. and prevent excessive heat buildup. This represents remarkably sophisticated engineering. Adjustable systems that balanced competing requirements for heat retention and toxic gas removal. But preventing shelter fires required more than hearth engineering and ventilation. It required sophisticated understanding of fuel behavior. Analysis of preserved hearth remains reveals that Ice Age humans didn't burn whatever combustible materials were available. They selected specific fuels based on burning characteristics. Chemical analysis of charcoal and ash deposits from Ice Age hearths, conducted by researchers at the Max Planck Institute, reveals distinct patterns. Different fuel types were used for different purposes and at different times. Wood selection shows sophisticated knowledge of burning temperatures and spark production. Hardwoods like oak and ash were preferentially used when available, because they burn at lower temperatures with minimal sparking. Softwoods like pine, which burn hotter and produce more sparks, were avoided for indoor use or used only during specific conditions. In regions without substantial tree coverage, Ice Age populations used alternative fuels but with equal sophistication. Mammoth dung, dried grasses, and animal bones show evidence of deliberate processing before burning. Preserved fuel preparation areas show evidence of systematic drying and processing. Fuels weren't used fresh. They were dried for extended periods to reduce moisture content and control burning characteristics. Bone fuel was deliberately broken into specific sizes to optimize burning. Duration and heat output. Modern combustion analysis shows that the processed fuels used in Ice Age hearths burned with substantially reduced spark production compared to unprocessed materials. This wasn't accidental. It was deliberate engineering to minimize ignition risks. Additionally, preserved hearth layers show evidence of fuel mixing. Rather than burning single fuel types, Ice Age populations combined different materials in specific proportions. Modern analysis reveals these mixtures optimized heat output while minimizing dangerous combustion behaviors. Archaeological evidence also reveals sophisticated fire management protocols, behavioral systems that controlled fire use within shelters. Preserved settlement patterns show evidence of designated fire-tending responsibilities. Analysis of activity areas within shelters reveals that specific zones were reserved for individuals responsible for fire maintenance. These zones show concentrated tool deposits, fuel storage, and evidence of sustained occupation near hearths. The existence of specialized fire-tending positions indicates systematic social organization around fire safety. Rather than allowing uncoordinated fire use, Ice Age communities assigned specific responsibilities for fire management. Preserved hearth structures show evidence of continuous maintenance. Ash deposits indicate regular cleaning. Stone arrangements show evidence of periodic reconstruction. Hearth boundaries were maintained and reinforced rather than allowed to degrade. This indicates that fire management wasn't casual or intermittent. It was continuous, systematic, and highly organized. Someone was always responsible for monitoring fire behavior. Most remarkably, preserved settlement records suggest that fires were never left unattended during sleeping periods. Evidence of nighttime activity around hearths indicates that watch rotations were maintained. Individuals responsible for monitoring fires throughout the night, while others slept. Modern analysis of preserved fuel consumption patterns supports this interpretation. Fuel deposits show evidence of regular small additions rather than large batch feeding. This suggests continuous tending rather than periodic inattention, followed by emergency refueling. But despite all precautions, fires occasionally escaped containment. Archaeological evidence reveals that Ice Age humans developed emergency suppression systems for controlling unplanned ignitions. Preserved hearth areas show evidence of strategically positioned materials that modern fire scientists recognize as suppressants. Sand deposits, clay stores, and water storage containers positioned near hearths at consistent locations across multiple sites. These weren't random material deposits. They were deliberately positioned emergency resources. Chemical analysis shows sand deposits near hearths have different compositions than general floor materials. They were brought from specific sources and positioned for rapid access. The positioning is consistent. Suppressant materials placed at distances of 3 to 5 feet from hearth edges. easily accessible but not in locations that would interfere with normal hearth use. This suggests standardized safety protocols. Additionally, many shelter excavations reveal evidence of designated exit routes. Preserved floor plans show that shelters weren't constructed with single entrances. They incorporated multiple openings positioned to provide escape routes from any location within the shelter. The multiple opening design served dual purposes: ventilation during normal operations and emergency egress during fire events. Modern building codes require similar provisions. Ice Age humans intuitively understood the same principle. Perhaps the most remarkable aspect of Ice Age fire safety was how this knowledge was transmitted across generations with sufficient precision to prevent catastrophic failures. Unlike written documentation, Ice Age populations relied on oral transmission and direct training. Yet the consistency of fire safety features across vast geographic distances and time periods indicates remarkably effective knowledge preservation. Preserved settlement patterns suggest formalized training systems. Evidence indicates that children were gradually introduced to fire management responsibilities through structured progression. Young children performed low-risk tasks like fuel collection and preparation. Adolescents assisted with hearth maintenance under supervision. Adults assumed full fire management responsibilities only after extended training periods. This systematic training approach ensured that critical fire safety knowledge was preserved and transmitted with minimal error. The high-stakes failure meant death created strong selective pressure for accurate knowledge transmission. Archaeological evidence also suggests that fire safety knowledge was transmitted through standardized protocols. The remarkable consistency of hearth construction, ventilation positioning, and fuel selection across vast distances indicates that specific techniques were preserved and transmitted as formal procedures rather than informal practices. Archaeological evidence also reveals that Ice Age fire management varied seasonally, with different protocols for different environmental conditions. Preserved settlement patterns show distinct seasonal variations in fire management. Winter shelters show evidence of more intensive fire use with enhanced safety features. Summer shelters show simpler fire management with reduced safety infrastructure. During extreme winter months when continuous fire use was essential for survival, Ice Age populations implemented maximum safety protocols, enhanced ventilation systems, increased fire-tending attention, and additional suppressant materials positioned around hearths. During milder seasons when fire use was less critical, simplified approaches were sufficient. This adaptive strategy demonstrates sophisticated risk management, applying maximum safety measures only when necessary rather than maintaining constant maximum precautions. The seasonal variation also extended to shelter construction. Winter shelters show evidence of more substantial construction and better integration of fire safety features. Summer shelters show lighter construction with less extensive fire engineering. This indicates that Ice Age populations understood that fire risk varied with usage intensity and environmental conditions. They adapted their safety measures accordingly, rather than applying uniform protocols regardless of circumstances. The true genius of Ice Age fire safety wasn't any single innovation. It was systematic integration. Ice Age populations didn't just build hearths. They built hearths and positioned them at calculated distances and engineered ventilation systems and selected appropriate fuels and maintained continuous fire monitoring and positioned emergency suppressants and trained systematic fire tenders and adapted protocols seasonally. Each element reinforced the others. Hearth engineering contained fires. Distance calculations prevented thermal ignition. Ventilation removed toxic gases. Fuel selection minimized sparking. Fire monitoring caught problems early. Emergency resources controlled escaped fires. Training ensured protocols were maintained. Seasonal adaptation optimized safety measures for varying conditions. Preserved settlement records from the Upper Paleolithic period show that successful long-term habitation sites consistently incorporated all these elements. Sites showing evidence of fire damage typically show simplified approaches, single-element solutions that proved insufficient. Modern fire safety engineering recognizes these same principles. Contemporary building codes require multiple integrated safety systems because no single element provides sufficient protection. Ice Age humans understood this intuitively and implemented comprehensive integrated approaches. Modern fire safety researchers studying Ice Age fire management have gained remarkable insights. Military survival training programs now teach hearth construction techniques directly derived from Ice Age archaeological evidence. Wilderness survival experts incorporate Ice Age fuel selection principles into training curricula. The National Fire Protection Association conducted a 2018 study analyzing Ice Age fire safety systems using modern fire modeling software. The results were extraordinary. Properly executed Ice Age fire management protocols provided fire safety comparable to contemporary primitive shelter designs that incorporate modern fire safety materials. Disaster relief organizations working in refugee situations have adapted Ice Age ventilation engineering principles for emergency shelter design. The systems work effectively with minimal materials and no industrial technology. When we examine the sophistication of Ice Age fire safety systems, the engineered hearth construction, the calculated distance positioning, the sophisticated ventilation systems, the strategic fuel selection, the systematic fire management protocols, the emergency suppression resources, the formalized training systems, the seasonal adaptation strategies, we see not desperate survivors hoping flames wouldn't escape, but accomplished safety engineers. Paleolithic humans didn't simply use fire recklessly and accept catastrophic casualties. They systematically engineered fire safety into every aspect of shelter design and daily living. They understood that fire in enclosed flammable spaces required multiple coordinated safety systems working together. Rather than any revolutionary single innovation, their genius lay in integration. They coordinated hearth design, spatial positioning, ventilation engineering, fuel selection, social organization, and behavioral protocols into complete systems that made continuous fire use survivable across thousands of years. The next time you light a fire in your modern fireplace with its engineered chimney, fire-resistant materials, and spark screens, remember that the fundamental principles you're relying on were first developed by families burning fires inside structures made entirely of kindling. Ice Age humans didn't defeat the fire paradox through luck or tolerance for casualties. They defeated it through something far more powerful, the recognition that even the most dangerous technology could be made safe through systematic engineering and disciplined management. Their fire wasn't primitive, it was revolutionary, and in the frozen darkness of the Ice Age, that revolution meant the difference between warmth and freezing, between survival and extinction, between controlled fire and catastrophic burning, for every human who ever closed their eyes beside flames, inside a shelter made of tinder.